The next example, again, we're looking into variables that have the exact same coefficients. Now, if they don't, he's under your desk. There we go. You don't have a sheet of paper out? OK. OK, good. So in this example, we don't have variables that have the exact same coefficients. All right? So the next thing to do is look for variables that have the simplest LCM, least common multiple, for their coefficients. Now, in this case, you could see I have 9 and 3, or 3 and 1. So it really, both of those are going to be easy to find the common multiple. So my best thing is, guys, instead of being indecisive, just make a decision. What would you like to solve for, A or D? You tell me what I should do. OK, so she wants to eliminate A. So basically, what we want to do is make sure that we have 9, and then we want this to be the same. So we want this to be -9. So what we're going to do is we're going to multiply by a multiplier, OK? Because the common multiple between, forget about the negative for a second. The common multiple between 9 and 3 is 9. Multiple is numbers that they multiply into, right? So the common denominator would be 3. But common multiple of 9 and 3 is 9. All right? So, but again, to add them, we want one to be positive, one to be negative. So what do I need to multiply this equation by so that it's -9? 3. So you multiply the whole equation by 3. Now, this sometimes gets students, because they're like, how can you do that? And they forget to multiply everything. So let me give you an example. If I said x equals 5, and I multiplied the equation by a multiple of 3, I would have 3x equals 15. Is the black equation the same as the blue equation? Yes. So as long as you multiply equation by the same number, you're not changing the solution to the equation. So we're going to multiply by 3. And what I'm going to do is I'm just going to rewrite the two equations. Now, by applying distributive property here, multiplying everything, I now have -9a plus 3d equals -3. Now, again, she's trying to focus on eliminating a. But something else important happens here. We actually are going to eliminate both variables when we do that. And I'll explain what happens when that goes. So now we add the two equations. And this goes to 0. This goes to 0. And that goes to 0. So now we have an equation where 0 equals 0. Well, remember, ladies and gentlemen, when we were graphing a system of equations, there's 3 types of systems. You could have it consistent, meaning there's an intersection point where there's only one point of intersection, or they're exactly the same line. Or we could have no solution, or an inconsistent system where there was no solution. So if you're doing elimination and even substitution, and you come up with an equation that's true, all right, 0 equals 0 is true, then you're going to have infinite many solutions. OK? Only if this was like changed, and you had it, and you produce an equation that is false, then you would say no solution, right? OK? So sometimes, you guys got to remember, sometimes you're going to get points like the first example I did. And then sometimes you're going to have ones that don't work.